In this lecture, we'll talk about SLR Parser. In this course on compiler design, we'll cover three methods of building a bottom-up parser. SLR Parser is one such method. Remaining two methods that we'll cover in this course are canonical and LLR parser, and we'll talk about them later. So first of all, let us begin with SLR parser. Before we talk about the method as to how we can build the SLR parser, let us discuss a few concepts and terms that we shall be needing later on. So we start by understanding what is an LR0 item. In LR0 item, I place a dot on the right hand side of the production. So for example, if my production is capital A derives BC, then I'll be placing the dot on the right hand side, either before B or between B and C, or after C at the rightmost position. So depending upon where you place a dot, I will be generating, for example, these three LR0 item for this particular production. So capital A derives dot BC, that is one such LR0 item, capital A derives B dot C, and capital A derives BC dot. If my production is capital A derives epsilon, then for this production, LR0 item will be capital A derives dot. To build the SLR parser, we first of all augment the grammar by adding a new start symbol S dash, and by adding a new production S dash derives capital S. So if the grammar is like this, I'll be adding a special production to this grammar S dash derives capital S. After augmentation, the grammar will be S dash derives capital S, and these two productions are the original productions of the grammar. The purpose of augmentation is for the parser to know when to stop the parsing. So when reduction based upon this production that has been added, it takes place, at that time parser comes to know that the given string is accepted and it was successfully parsed. LR0 item can be classified into the two categories. The first one is the kernel item, and the second one is the non-kernel item. All those LR0 item in which dot is not at the leftmost position, they are kernel item. For example, capital A derives B dot C, the dot is not at the leftmost position, so this is a kernel item. Similarly, capital A derives BC dot, dot is not at the leftmost position, so this is also a kernel item. Now the LR0 item, S dash derives dot S, this is a special LR0 item in which the dot is at the leftmost position, but this is considered to be a kernel item. Now the non-kernel item in which the dot is at the leftmost position, they are considered to be the non-kernel item. For example, capital A derives dot BC, the dot is at the leftmost position, so this is a non-kernel item. Now once again, the LR0 item S dash derives dot S, it's a special LR0 item which is considered to be kernel, though the dot is at the leftmost position, but it is not considered to be non-kernel, rather it is considered to be a kernel LR0 item. We will now learn how to calculate the closure of a set of LR0 items. Let me just assume that I have a set of LR0 item given in which there is only single LR0 item, capital F derives bracket open dot capital E bracket close. For this set, I want to calculate the closure. So first of all, whatever items which are there in the set, they will be added to the closure. So I begin by adding capital F derives bracket open dot capital E to the closure. Now after the dot I have the variable capital E, so I look at the production of the variable capital E, and I will add LR0 item corresponding to the production of the variable capital E I have these two production of the variable capital E. So now I add the LR0 item corresponding to these two production, which are capital E derives dot E plus T and capital E derives dot T. Now this will be done repetitively till no more items can be added to the closure set. So after the dot I have the variable capital T. So I will add LR0 item corresponding to the production of the variable capital T to the closure. So now I add capital T derives dot T star F, and I add capital T derives dot F. Once again, after the dot I have the variable capital F, so I will add capital F derives dot bracket open, capital E bracket close, and capital F derives dot identifier. Now no more item will be added to the closure set, so this is where we stop, and this is the closure of the set of LR0 item given over here. We will now understand one more function, which is goTo, before we start learning how to construct the SLR parsing table. Now the goTo function is calculated for a set of LR0 item and for some given grammar symbol. Let me denote the set of LR0 item by I, and let me denote the given grammar symbol by X, and let me assume that my set is containing the LR0 item, capital A derives alpha dot X beta, and I want to calculate goTo from the set I on the grammar symbol X. So what I do is I shift the dot after the variable capital X, so after the grammar symbol capital X. So I obtain now the LR0 item, capital A derives alpha X dot beta, and I take the closure of this, and that becomes the goTo from the set I on the grammar symbol X. Let me now take an example. I have this grammar given. This grammar is accepting arithmetic expression, and this grammar is unambiguous grammar. And I have a set of LR0 item given, which is containing two LR0 item shown over here, and I want to calculate from this set I on the grammar symbol plus. And if you examine this set of LR0 item, there is one item which is containing a plus symbol after the dot. So what I do is, in order to calculate the goTo, I shift the dot after the plus, and I obtain this LR0 item, capital E derives E plus dot T. So I add this, and now I take the closure of this. Immediately after the dot I have the variable capital T, so I add LR0 item corresponding to the production of the variable capital T. I have these two production from the variable capital T, so I add these two LR0 item to the goTo. Capital T derives dot T star F, and capital T derives dot F. Once again, immediately after the dot I have the variable capital F, so I add LR0 item corresponding to the production of the variable capital F. I have these two production of the variable capital F, so I add these two LR0 item corresponding to the variable capital F. Capital F derives dot within bracket capital E, and capital F derives dot identifier, and this becomes the goTo on the grammar symbol plus from the given set I. Reduction is one of the operations performed by the bottom-up parser, and in the SLR parsing table, reduction takes place based upon the follow-up variable, and we'll try to understand the reason behind this. Let's assume that we have a grammar in which there is a production capital A derives beta, and as you know that in the bottom-up parsing we are performing the rightmost derivation in the reverse order. So here I have an example of the rightmost derivation. We are starting the derivation from the starting variable capital S, and let us assume that after some steps of the rightmost derivation, I obtain the right sentential form alpha capital A small b and w. In this right sentential form, alpha is a string consisting of variable as well as terminal symbol. Capital A is the variable of the grammar, and small b is the terminal symbol, and w is a string consisting of terminal symbols only. So that means in this right sentential form, after the variable capital A, there are only terminal symbols. So in this sentential form, capital A is the rightmost variable. So in the next step of the derivation, this variable will be expanded or replaced to obtain the next sentential form. The second point that is to be noted here is, in this sentential form, small b is following the variable capital A. So small b is a terminal symbol which is representing the follow of the variable capital A. And since in the bottom-up parsing we are performing the rightmost derivation in the reverse order, so that means during the course of the parsing, first of all I will obtain this sentential form, and then in the next step I will obtain the previous sentential form. So if I look at this sentential form, beta, which is a handle in this sentential form, will be reduced to the variable capital A in order to obtain the previous right sentential form. So when I do this reduction, small b will be the next symbol, which is the symbol there in the follow of the variable capital A. So that is why we are performing the reduction based upon the follow in the SLR parsing table. We will now learn how to construct the SLR parsing table, and we'll construct the SLR parsing table for the unambiguous grammar recognizing arithmetic expression consisting of addition and multiplication operator. First of all, we'll augment the grammar by adding a special production E dash derives capital E, where capital E is the starting variable in my original grammar. And we have introduced a new variable E dash in my augmented grammar. Followed by this, I begin the construction of the state. So I start from the state number 0, and to each state we'll add the LR0 item, and I start by adding the special LR0 item to the state number 0, and that item is E dash derives dot capital E. And after adding this item, I take the closure of this. Immediately after the dot, I have the variable capital E. So I will add LR0 item corresponding to the production of the variable capital E. From the variable capital E, I have these two production. So these two LR0 item have been added accordingly. So capital E derives dot E plus T and capital E derives dot T. Now in this LR0 item, after the dot I have the variable capital E which I have already considered, and in this LR0 item, after the dot I have the variable capital T. So I will add LR0 item corresponding to the production of the variable capital T. So from the variable capital T, I have these two production. So for these two production, these LR0 item have been added to the state number 0. Now in this LR0 item, after the dot I have capital T which I have already considered, and in this LR0 item, after the dot I have the variable capital F. So I will add LR0 item corresponding to the production of the variable capital F. So from the variable capital F, I have these two production. So I will add the LR0 item to the state number 0. Capital F derives dot within bracket capital E, and capital F derives dot identifier. Now we can see that no more LR0 item will be added to the state number 0, and my state number 0 is complete. Now we'll consider a transition from state number 0. Whatever symbols that we have after the dot in the LR0 item, they will be transition on those symbols. So if I look, for example, look at these two LR0 item, after the dot I have the variable capital E, so there will be transition on capital E. Now in this LR0 item, after the dot I have capital T, so there will be transition on capital T. Similarly, for corresponding to this LR0 item, there will be transition on capital F, and there will be a transition on opening bracket, and there will be transition on identifier. Now in this part of the slide, I'm showing the transitions from the various state. From state number 0, I have a transition on capital E. From state number 0, I have a transition on capital T, capital F, identifier, and opening bracket. Now let's consider each transition one by one. And first of all, we'll consider the transition on capital E from state number 0. So from state number 0 on capital E will go to the state number 1. And now we have to identify what LR0 item will be added to the state number 1. So to do this, I will shift the dot after capital E, since we are considering the transition on capital E. So for this LR0 item, dot will be shifted after capital E, and for this LR0 item, dot will be shifted after capital E. So these two LR0 item have been added to the state number 1. Now we take the closure of this. Here after the dot I do not have a grammar symbol, and here after the dot I have a terminal symbol. So even after taking the closure, no more LR0 item will be added to the state number 1, and now my state number 1 is complete. Let's now move on to the next transition from state number 0. From state number 0 on capital T, we are going to state number 2. So from state number 0 on capital T, we are going to the state number 2, and let us now find out what LR0 item will be there in the state number 2. So I will shift the dot after capital T. So for this LR0 item, I will add to the state number 2 capital E derives T dot, and similarly for this also I will add E derives T dot star F. And after doing this, we'll once again take the closure of this. Here after the dot I do not have a grammar symbol, and here after the dot I have a terminal symbol. So even after taking the closure, no more LR0 item will be added to the state number 2, and my state number 2 is complete. Let's consider now the next transition from the state number 0. Next transition is on capital F. So from state number 0 on capital F, we are going to the state number 3. From state number 0 on capital F, we are going to the state number 3. And let's now find out what LR0 item will be there to the state number 3. So for this, I shift the dot after capital F, and to the state number 3 I add capital T derives F dot. And I take the closure of this. After the dot I do not have any grammar symbols, so even after taking the closure, no more LR0 item will be added, and my state number 3 is complete. Let's now consider the next transition from state number 0, which is on opening bracket. And from state number 0 on opening bracket, we are going to the state number 4. From state number 0 on opening bracket, we are going to the state number 4. So state number 4 will contain the LR0 item. Capital F derives opening bracket dot capital E and opening bracket close. The dot has been shifted after the opening bracket. And now we take the closure of this. Immediately after the dot, I have the variable capital E in this LR0 item. So I will add LR0 item corresponding to the production of the variable capital E. So these two have been added because of this. And once again, look at this LR0 item. I have a variable capital T after the dot, so I will add a production LR0 item corresponding to the production of the variable capital T. So these two have been added due to this. And after the dot here, look at this LR0 item. After the dot, I have the variable capital F. So I will add LR0 item corresponding to the production of the variable capital F. So they have been added. These two LR0 items have been added due to this. Now we can see that no more LR0 item will be added, and my state number 4 is complete. Now here, like in the yellow color, the LR0 item that I'm showing, they are the LR0 item which have been obtained after taking the closure. And the one that I'm showing in the white color, they are the LR0 item that have been obtained by shifting the dot from the previous state. Let's now consider the next transition from state number 0. Next transition is on identifier. From state number 0 on identifier, I'm going to the state number 5. So state number 5 will contain the LR0 item. Dot will be shifted after identifier. So it will contain the LR0 item. If derives identifier dot. And now I take the closure of this. After the dot, I do not have any grammar symbol. So even after taking the closure, no more LR0 item will be added. And my state number 5 is complete. Let us now move on to the next state, which is I1, and consider the transition from I1 state. In the I1 state, there are two LR0 items. In the first LR0 item, dot is at the rightmost position and there is no grammar symbol after the dot. So there will not be any transition corresponding to the first LR0 item from I1 state. In the second LR0 item, I have the plus symbol after the dot. So from I1 on plus symbol, there will be a transition. So from the I1 state on plus symbol, I'm going to I6 state. And let us now add LR0 item to the I6 state. So first of all, I'll shift the dot after the plus symbol, and to the I6 state I will add capital E derives E plus dot T. Now this is the kernel LR0 item. I now take the closure of this. After the dot I have the variable capital T. So I will add LR0 item corresponding to the production of the variable capital T. So these two LR0 items have been added based upon this. Now in this LR0 item, after the dot I have the variable capital F. So now I will add LR0 item corresponding to the production of the variable capital F. So these two LR0 item have been added based upon this. No more LR0 item will be added to the I6 state, and my I6 state is now complete. And we have also considered all the transitions which are possible from the I1 state. I now move on to the next state, which is I2, and consider the transition from I2 state. Once again in the I2 state, there are two LR0 items. In the first LR0 item, dot is at the rightmost position and there is no grammar symbol after the dot. So first LR0 item will not give rise to any transition from I2 state. In the second LR0 item, after the dot I have the symbol star. So from I2 state on star there will be a transition. And from I2 state on star I am going to I7 state. And let us now add LR0 item to the I7 state. So first of all, I'll shift dot after star, and to the I7 state I add capital T derives T star dot F. This is the kernel LR0 item which has been added to the I7 state. I now take the closure of this. After the dot, I have the variable capital F. So I will add LR0 item based upon the production of the variable capital F. So these two LR0 item have been added based upon this. No more LR0 item will be added to the I7 state, and my I7 state is now complete. I go back to I2 state, and we have considered all the transitions from I2 state. I now move on to the next state, which is I3. In I3 state, there is a single LR0 item, and in that LR0 item, the dot is at the rightmost position, and there is no grammar symbol after the dot. So this LR0 item will not give rise to any transition from I3 state. So there will not be any transition from the I3 state. I now move to the next state, which is I4, and consider the transition from I4 state. So let's look at the first two LR0 item. After the dot, I have the variable capital E. So these two LR0 item will give rise to transition from I4 on capital E. So from I4 on capital E, I'm going to I8 state. And let us now add LR0 item to the I8 state. So I'll be shifting dot after capital E, and to the I8 state I will add capital F derives opening bracket capital E dot the bracket close. And for this LR0 item, I'll shift dot after capital E, and to the I8 state I will add capital E derives E dot plus T. Now in these two LR0 item, here I have a terminal symbol after the dot, and here also I have a terminal symbol after the dot. So even if I take the closure, there no more LR0 item will be added to the I8 state. So my I8 state is complete. Let us now go back to the I4 state and consider other LR0 item. In these two LR0 item, after the dot I have the variable capital T. So from I4 state on capital T there will be transition. From I4 state on capital T, I will go to the state which is containing the LR0 item. Capital E derives T dot and T derives T dot star F. And if we look at the states that we have already formed, there is already a state which is containing these LR0 item, so which is I2. So from I4 on capital T, I am going to I2 state. From I4 on capital T, I am going to I2 state. From I4 in this LR0 item, I have capital F after the dot. So there will be transition on capital F from I4. And from I4 on capital F, I'll go to the state which is containing LR0 item. Capital T derives F dot. And if we look at the existing state, there is already a state which is containing the same LR0 item. So from I4 on capital F, I'll go to I3 state. Now moving on to the next LR0 item. From I4 on the after the dot, I have the opening bracket. So in this LR0 item, so there'll be a transition from I4 on opening bracket. So from I4 on opening bracket, I will go to the state which is containing the LR0 item. Capital F derives opening bracket dot capital E bracket close, and the closure of that. And if we examine the existing state, I4 state is already containing these LR0 item. So capital F derives opening bracket dot capital E and bracket close. So from I4 on opening bracket, I will remain in the I4 state. Moving to the last LR0 item from I4 state, there will be a transition based upon this LR0 item. There will be a transition from I4 on identifier. So from I4 on identifier, I'm going to I5 state, and I5 state is containing the LR0 item. Capital F derives identifier dot will shift after identifier. And we have considered all the transitions which are possible from I4 state. Let us now move on to the next state, which is I5, and consider the transition from I5 state. In I5 state, there is a single LR0 item, and in this LR0 item, dot is at the rightmost position, and there is no grammar symbol after the dot. So this LR0 item will not give rise to any transition from I5 state. So there will not be any transition from I5 state. I now move on to the next state, which is I6, and consider the transition from I6 state. If I look at the first two LR0 item in I6, after the dot, I have the variable capital T. So from I6 state on capital T, there will be a transition, and from I6 state on capital T, I'm going to I9 state. And let us now add LR0 item to the I9 state. So I will shift dot after capital T, and I will add to the I9 state capital E derives E plus T dot. And similarly for the second LR0 item, I'll shift dot after capital T, and to the I9 state I will add capital T derives T dot star F. I now take the closure of I9 state. In the first LR0 item, there is nothing after dot, and in the second LR0 item, I do not have a variable after the dot. So even after taking the closure, no more LR0 item will be added to the I9 state, and I9 state is now complete. Coming back to I6 and considering the remaining transition from I6. From I6, in this LR0 item, there is capital F after the dot, so there will be transition from I6 on capital F. From I6 on capital F, I'll go to the state which is containing capital T derives F dot, and if I examine the existing state, there is already a state which is containing this LR0 item, so which is I3. So from I6 on capital F, I'll go to I3 state. Going back to the I6 state and considering the remaining transition, from I6 on opening bracket, there will be a transition based upon this LR0 item, and I will go to the state which is containing the LR0 item, capital F derives opening bracket dot capital E bracket close, and the closure of that. And if we examine the existing state, there is already a state which is I4 containing the same LR0 item. So from I6 on opening bracket, I'm going to I4 state. Then we have the last LR0 item in I6, which is capital F derives dot identifier. So from I6 on identifier, there will be a transition, and from I6 on identifier, I'm going to the state which is containing the LR0 item. Capital F derives identifier dot, and there is already a state which is containing this LR0 item, which is I5. So from I6 on identifier, I'll go to I5 state. So we have considered now all the transitions which are possible from the I6 state. I now move on to the next state, which is I7, and consider the transition from I7 state. In the first LR0 item, after the dot, I have the variable capital F. So from I7, there will be transition on capital F. So from I7 on capital F, I'm going to I10 state. And let us now add LR0 item to the I10 state. So I'll shift dot after capital F, and to the I10 state, I will add capital T derives T star dot F. I now take the closure of this. After the dot, I do not have a grammar symbol, there is no variable. So even after taking the closure, no more LR0 item will be added to I10 state. Now considering the remaining transitions which are from I7 state. From I7 on opening bracket, I'll go to the state which is containing the LR0 item. Capital F derives opening bracket dot capital E bracket close, and there is already a state which is containing this, which is I4. So from I7 on opening bracket, I'll go to I4 state. And looking at the last LR0 item in I7, from I7 on identifier, I'll go to I5 state. So we have considered all the transitions which are possible from I7 state. Now moving on to the next state, which is I8. And if I look at the transitions from I8 state, in the first LR0 item, after the dot I have the plus symbol. So from I8 on plus symbol, I'll go to the state which is containing the LR0 item, capital E derives E plus dot T. And the closure of that. And if I look at the existing state, I6 is containing the same LR0 item. Capital E derives E plus dot T and the closure of this. So from I8 on plus, I'll go to I6 state. In the next LR0 item in the I8 state, after the dot, I have the closing bracket. So from I8 on closing bracket, I'll go to the state I11. And let us now add LR0 item to the I11 state. Dot will shift after the closing bracket, and to the I11 state I will add capital F derives within bracket capital E dot. I now take the closure of this, so even after closure, no more LR0 item will be added to I11 state. So we have considered all the transitions which are possible from I8 state. I now move on to the I9 state. There are two items in the I9 state. In the first LR0 item, dot is at the rightmost position, so there will not be any transition corresponding to the first LR0 item. Looking at the second LR0 item, after the dot I have the star, and there will be transition from I9 on star. And I will go to the state which is containing the LR0 item, T derives T star dot F. And if I look at the existing state, there is already a state which is containing this LR0 item, which is I7. So from I9 on star, I will go to I7 state. And we have considered now all the transitions which are possible from I9 state. Now we move on to the next state, which is I10. In I10 state, there is single LR0 item, and in this, the dot is at the rightmost position, so there will not be any transition from I10 state. And let us now move to the next state, which is I11. And in this state also, there is single LR0 item, and the dot is at the rightmost position. So this LR0 item will also not give rise to any transition, so there will not be any transition from I11 state. So this way we have completed our state construction. We have identified all the possible states, and we have considered identified all the transitions which are possible from the various states. Now these states that we have constructed, they will be the basis for constructing the parsing table, and we'll learn now how to construct the parsing table based upon this information. Before we learn how to construct the SLR parsing table, let us try to understand the significance of various states. Significance of a state can be interpreted based upon the LR0 item which are there in that state. For example, in the I0 state, which is the initial state of the parser has not processed any input symbol. And if I look at the first LR0 item, after the dot I have the capital E. So in the I0 state, parser is expecting the string derivable from capital E. And these two items have been added because of this capital E. So it means that in the I0 state, parser is expecting the string derivable either from E plus T or from capital T. Now these two LR0 items have been added because of this LR0 item, because of this capital T. So it means that in the I0 state, parser is expecting the string either derivable from the production T star F or from the production T derives F. And these two LR0 items have been added because of this capital F. So in the I0 state, the parser is expecting the string derivable from within bracket capital E and derivable from or the identifier itself. Now let us try to understand the significance of I4 state. Let's consider the first LR0 item. Whatever we have before the dot, that is what parser has already seen. And whatever we have after the dot, parser is expecting that. So if I interpret the first LR0 item, it means that in the I4 state, parser has already seen the opening bracket, and now parser is expecting the string derivable from capital E, and followed by that it is expecting the closing bracket. Now these two LR0 items have been added because of this capital E. So the string which is derivable from capital E will either be derivable from this production or it will be derivable from this production. Similarly for the remaining LR0 item also. Let us now understand the significance of I6 state. And in the I6 state, if I look at the first LR0 item, before the dot I have E plus. It means that when the parser is in the I6 state, it has already seen a string derivable from capital E, and followed by that it has already seen a plus symbol, and now it is expecting the string derivable from capital T. And these two LR0 items have been added because of this capital T. So any string which is derivable from capital T will either be derivable from this production or it will be derivable from this production. And because of this capital F, which is after dot, these two LR0 items have been added. So any string which is derivable from capital F will either be derivable from this production or it will be derivable from this production. Similarly, let us now understand the significance of I5 state. In the I5 state, I have the LR0 item, capital F derives identifier dot. So when the parser goes into I5 state, it has already seen identifier and dot has shifted after identifier, and now in the I5 state, identifier will be reduced to capital F. So that is the significance of I5 state. So by looking at the LR0 item which are there in various state, we can understand the significance of each state. We will now learn how to construct the SLR parsing table. And as discussed in the earlier lecture, that LR parsing table is a two-dimensional table where rows are indexed on the basis of states and columns are divided into two regions, action region and go-to region. Action region of the parsing table is indexed on the basis of terminal symbols, and go-to region of the parsing table is indexed on the basis of variables in the grammar. Now we have identified 12 number of states from I0 to I11. So there will be a row in the parsing table corresponding to each state. So we have, as you can see, that we have 12 number of rows in the parsing table, one corresponding to each state from 0 to 11. Let us now learn how do we fill the entries in the parsing table. To fill the entries in the parsing table, we'll look at the transition from the state, and we'll look at the LR0 item which are there in the state, and accordingly we will fill the entries in the parsing table. So if there is a transition on the terminal symbol from a state, it will give rise to shift operation in the parsing table. The second point is that if there is a transition from a state on some variable, then in that case it will give rise to an entry in the go-to region of the parsing table. And if there is, the third point is, if there is a LR0 item in the state in which the dot is at the rightmost position, then it will give rise to reduction operation in the parsing table. Now, as discussed earlier, that reduction is done in the SLR parsing table using the follow of the variable. So we'll be requiring the follow of the variables in the grammar. So we have already calculated the follow of the various variable. The follow of capital E is dollar plus and right parenthesis, and we can easily verify it from the grammar. Capital E is the starting variable, so dollar will be there. And I'll look at this production, plus is following capital E, and look at this production, right parenthesis following capital E. So the follow of capital E is dollar plus and right parenthesis. Now coming to follow of capital T. Follow of capital T will be, let's look at the production number 2. Whatever symbols which are there in the follow of E, they will be added to the follow of T. So that means dollar plus and right parenthesis, they will be there in the follow of T. And look at the production number 3, star is following capital T, so star will also be there in the follow of T. So the follow of T now contains dollar plus star and right parenthesis. Now let us calculate the follow of capital F. Let's look at the production number 4. Production number 4 is capital T derives F, and based upon this, all the symbols which are there in the follow of T, they will be added to the follow of F. So follow of F will contain dollar plus star and right parenthesis. So these are the follow of the various variables that we have in the grammar. Let us now start considering the various states and start filling the entries in the parsing table. We'll take first of all the state number 0. Let us now consider the transitions which are there from the state number 0. From state number 0 on capital E, we are going to the state number 1. So since this is a transition on a variable, so it will give rise to entry in the go-to region of the parsing table. So you can see that from state number 0 on capital E, we are going to the state number 1. So this one has come because of this transition. Let's now consider another transition from the state number 0. From state number 0 on capital T, we are going to the state number 2. So once again, it is a transition on variable. It will give rise to an entry in the go-to region of the parsing table. So here you can see that 0 comma capital T, this entry is marked as 2. Let's take now the next transition from the state number 0. From state number 0 on capital F, I am going to the state number 3. Once again, it is a transition on the variable. So it will give rise to entry in the go-to region of the parsing table. So you can see that 0 comma F is 3. Let's take now another transition from the state number 0. From state number 0 on identifier, we are going to the state number 5. And since this transition is on a terminal symbol, so it will give rise to a shift operation in the parsing table. So 0 comma identifier, it is shift, and since we are going to the state number 5, so it is going to be S5. So this entry is S5 in the parsing table. Let's take now another transition from the state number 0. From state number 0 on opening bracket, we are going to the state number 4. So once again, this transition is on a terminal symbol. So it will give rise to a shift operation in the parsing table. So 0 comma opening bracket in the parsing table, this entry is marked as shift, and we are going to the state number 4. So this is S4. Let's now look at the entries which are there the LR0 items which are there in the state number 0. There is no LR0 item in which the dot is at the rightmost position. So we have considered now all the entries corresponding to the state number 0. So this way now we move on to the state number 1, and let us now consider the transition from the state number 1. From state number 1 I have a single transition. From state number 1 on plus I'm going to the state number 6. It's a transition on terminal symbol, so it will give rise to a shift operation in the parsing table. So 1 comma plus is going to be shift, and we are going to the state number 6, so this entry is 6. Let us look at the LR0 item which are there in the state number 1. There is LR0 item in which the dot is at the rightmost position, but this LR0 item is a special LR0 item. This production was added by augmenting the grammar. So it is so for this special LR0 item, we add the entry in the parsing table, state number 1 comma dollar. This is going to be the accept entry. So the significance of this is, since the dot is at the rightmost position, it means that parser has already seen a string derivable from capital E, which is the starting variable in my original grammar. So now the parser, there should be nothing remaining in the input buffer, and if the next symbol is dollar, then in that case the given string is accepted. So 1 comma dollar is marked as accept entry in the parsing table. Let us now move on to the next state, which is the state number 2, and let us consider the transition from state number 2. From state number 2 on a star, we are going to the state number 7. Now this is a transition on terminal symbol. So 2 comma star will be marked as shift, and we are going to the state number 7. So 2 comma star is 7. Let us now look at the LR0 item which are there in the state number 2. There is LR0 item in which the dot is at the rightmost position. So this is production number 2. So in the state number 2, I will also perform the reduction based upon production number 2 for the symbols which are there in the follow of E. So the follow of E is dollar comma plus comma right parenthesis. So that means in the state number 2, when the next symbol is either dollar or plus or right parenthesis, will add reduction based upon production number 2. So you can see here that 2 comma plus is reduction based upon production number 2, 2 comma right parenthesis is reduction based upon production number 2, and 2 comma dollar is reduction based upon production number 2. So we have now considered the entries corresponding to the state number 2. And now we move on to the state number 3. There is no transition from the state number 3, and we examine the LR0 item which are there in the state number 3. There is one LR0 item in which the dot is at the rightmost position. So this will give rise to reduction based upon this is production number 4. So this will give rise to reduction based upon production number 4 for the symbols which are there in the follow of T, and we have already calculated the follow of T over here. So in the state number 3, if the next symbol is a symbol which is the follow of T, for those symbols I will add reduction based upon production number 4. So you can see that in the state number 3 I have reduction based upon production number 4 for plus, for star, for right parenthesis, and for dollar. Now we move on to the next state, which is the state number 4, and first of all we consider the transitions which are there from the state number 4. From state number 4 on capital E we are going to the state number 8, and it is a transition on variable, so it will give rise to an entry in the go to region of the parsing table. So 4 comma E will be 8. So and you can see here that 4 comma E, this entry is marked as 8. Let's look at now the another transition from the state number 4. From state number 4 on capital T, we are going to the state number 2. Once again, this is a transition on variable. So it will give rise to an entry in the go-to region of the parsing table. So 4 comma T will be marked as 2. So you can see that 4 comma T, this entry is marked as 2. Let's now look at the next transition from the state number 4. From the state number 4 on capital F, we are going to 3. Once again, it is a transition on variable. So it will give rise to an entry in the go-to region of the parsing table. So 4 comma F will be marked as 3. And you can see here in the parsing table that 4 comma F is marked as 3. Let's now look at the next transition from the state number 4. From state number 4 on opening bracket, we are going to state number, we are remaining in the state number 4. Now this is a transition on the terminal symbol. So 4 comma opening bracket will be marked as shift 4, and you can see here that 4 comma opening bracket, this entry is marked as S4. Similarly, from the state number 4 on identifier, we're going to state number 5. Once again, a transition on terminal symbol giving rise to shift operation in the parsing table. So 4 comma identifier will be S5, and you can see here that 4 comma identifier is S5. Let us now look at the state number 5. From state number 5, there is no transition. And now we look at the LR0 items which are there in the state number 5. In state number 5, there is only one LR0 item in which the dot is at the rightmost position. So this LR0 item will give rise to reduction operation in the parsing table. Now this production is production number 6. So in the state number 5, we'll perform reduction based upon production number 6 for the symbols which are there in the follow of capital F. Follow of capital F is containing dollar plus star and right parenthesis. So you can see that in the state number 5, we are performing reduction based upon production number 6 for the symbol being plus star, right parenthesis and dollar, which are the symbols there in the follow of capital F. Let us now move on to the state number 6, and let us first of all consider the transitions which are there from the state number 6. From state number 6 on capital T, we are going to the state number 9. It is a transition on a variable, so it will give rise to an entry in the go-to region of the parsing table. So 6 comma capital T will be 9, and you can see here that 6 comma capital T is 9. Let's take now another transition from the state number 6. From state number 6 on capital F, we are going to state number 3. Once again, a transition on variable. So it will give rise to an entry in the go-to region of the parsing table. So 6 comma F will be 3, and you can see here in the parsing table that 6 comma F is, this entry is marked as 3. Another transition from the state number 6 is from state number 6 on opening bracket, we are going to the state number 4. It's a transition on terminal symbol, so it will give rise to a shift operation. So 6 comma opening bracket, the entry will be marked as S4. So 6 comma opening bracket, this entry is marked as S4. Let us now look at another transition from the state number 6. From the state number 6 on identifier, we are going to state number 5. Once again, a transition on terminal symbol. So 6 comma identifier will be marked as S5. So 6 comma identifier here in the parsing table is marked as S5. So we have considered all the transitions which are possible from the state number 6, and let us now examine the items which are there in the state number 6. There is no item in which the dot is at the rightmost position. So we have processed the state number 6, all the entries that should be there corresponding to the state number 6 in the parsing table. Now we move on to the state number 7, and we first of all consider the transitions from which are there from the state number 7. From state number 7 on capital F, we are going to the state number 10, and once again a transition on variable giving rise to an entry in the goto region. So 7 comma f will be 10, and 7 comma f, this entry is marked as 10 in the parsing table. Let's look at now the next transition from the state number 7 on opening bracket. We are going to the state number 4, transition on terminal symbol. So 7 comma opening bracket in the parsing table will be marked as S4. So see here, this entry is marked as S4. Let us now look at the next transition from the state number 7. From 7 on identifier, we are going to the state number 5. Once again, a transition on terminal symbol. So 7 comma identifier will be marked as S5, and you can see here that 7 comma identifier is marked as S5. We have considered all the transition from the state number 7, and let us now examine the LR0 item which are there in the state number 7. There is no LR0 item in which the dot is at the rightmost position, so state number 7 has been processed. Let's now move on to state number 8. First of all, let us consider the transitions which are there from the state number 8. From state number 8 on plus, we are going to 6, transition on terminal symbol. So 8 comma plus in the parsing table, this entry will be marked as S6. So 8 comma plus is marked as S6 in the parsing table. Let's now look at the next transition from the state number 8. From state number 8 on opening bracket, we are going to the state number 11. So once again, a transition on a terminal symbol. So entry in the parsing table at 8 comma closing bracket. This will be marked as S11. So 8 comma closing bracket is marked as S11. Let us now look at the LR0 item which are there in the state number 8. We have already considered the transitions from the state number 8, and there is no LR0 item in the state number 8 in which the dot is at the rightmost position, so the state number 8 has been processed. Let us now move on to the next state, which is state number 9. And first of all, let us consider the transition from state number 9. From state number 9 on a star, we are going to 7, a transition on terminal symbol. So entry in the parsing table at 9 comma star will be S7. So 9 comma star, this entry is S7. We have considered all the transitions which are possible from the state number 9, and let us now examine the LR0 item which are there in the state number 9. There is one LR0 item in which the dot is at the rightmost position, and this is production number 1. So in the state number 9, we'll perform reduction based upon production number 1 for the symbols which are there in the follow of E. Follow of E is containing dollar, plus, and right parenthesis. So you can see here in the parsing table in the state number 9, when the next symbol is plus, it is reduction based upon production number 1. Next symbol is closing bracket, reduction based upon production number 1, and when the next symbol is dollar, reduction based upon production number 1. So we have processed the state number 9, and let us now move on to the next state, which is state number 10. There is no transition from the state number 10, and let us now examine the LR0 item which are there in the state number 10. There is one LR0 item in which the dot is at the rightmost position, and this is production number 3. So in the state number 3, I'll perform reduction based upon production number 3 for the next symbol being the symbol which are there in the follow of T. And follow of T is plus, dollar, star, and closing bracket. So in the state number 10, we are performing reduction based upon production number 3 for the next symbol being plus, star, right parenthesis, and dollar. Let's now look at the last state, which is state number 11, and there is no transition from the state number 11. And let us now examine the LR0 item which is there in the state number 11. There is one LR0 item in which the dot is at the rightmost position. So once again, there will be reduction in the state number 11. Now this is production number 5. So in the state number 11, I'll perform reduction based upon production number 5 for the symbols which are there in the follow of if. Follow of if is containing dollar plus star and the right parenthesis. So you can see here in the state number 11 in the parsing table, this entry is marked as R5, R5, and when the next symbol is right parenthesis, it is R5, and when the next symbol is dollar, it is R5. So we have considered all the state, and we have filled the entries in the parsing table corresponding to every state, and now my parsing table is complete. So this is how we construct the parsing table from for a given grammar, and I hope that you would have understood the method for constructing the SLR parsing table.